Welcome to you all in my YouTube channel Experienced Mathematics. Today I am with a theorem to prove vectorially that the diagonals of a parallelogram bisect each other. Before starting, I want you to make sure that you please subscribe my channel if you have not already subscribed, so that I will be encouraged to make similar videos, and also press bell icon so that you will be informed about coming videos. So now I'll start my today's topic. Prove vectorially that the diagonals of a parallelogram bisect each other. Before starting, I want to tell something about vectorial proof of the theorem. Many theorems in plane geometry can be proved with the help of the vector. Okay, in this connection, this theorem to prove diagonals of a parallelogram bisect each other, this can also be proved by using vector. Okay, so this is important question. This question has already been asked in board examinations. So watching this video, I hope you will be benefited. So now I'll start this. I will draw the figure for this. Okay, here O, A, B, C. This OA, CB is a parallelogram. Let OA equals to vector A, OB equals to vector B. And this OC is one diagonal. Similarly, AB is another diagonal. Okay, this OC and AB, they are diagonals of the parallelogram. They bisect each other. We have to prove. Now look at the proof of this. Let OA CB be a parallelogram, okay, in which OA vector equals to vector A and OB vector equals to vector B. Okay, so this OA is vector A and OB is vector B. This we have supposed. And now OC vector equals to, we can write OA vector plus AC vector. Okay, going from O to C, same as going from O to A and A to C, right? Or we can write this as OA vector is vector A plus AC vector is same as OB vector. So this will be vector A plus vector B. Okay, so without writing like this, directly by using parallelogram law of vector also, OC vector equals to, we can write OA plus OB also. So OC equals to, we have got vector A plus vector B. Now then position vector of midpoint of diagonal OC is OC vector over 2. Okay, so this divided by 2 gives the position vector of the midpoint of the diagonal OC. So this equals to OC vector is vector A plus vector B over 2. This is the position vector of the midpoint of diagonal OC. And now using midpoint theorem, by using midpoint theorem for vectors, position vector of midpoint of diagonal AB equals to, that is vector OA plus vector OB over 2. Position vector of the midpoint of diagonal AB is OA plus OB over 2. You know the midpoint theorem for the vectors, and here OA vector is, from here it is vector A plus OB vector from here is vector B over 2. And your position vector of midpoint of the diagonal OC is A plus B over 2. Position vector of midpoint of diagonal AB is also A plus B over 2. Position vector of midpoint of both the diagonals are same, so the diagonals of a parallelogram bisect each other. Okay. So now we will conclude. Since position vector of midpoint of both diagonals OC and AB, position vectors of midpoint of both diagonals OC and AB are same. Okay, position vector of midpoint of both the diagonals OC and AB are same, so the diagonals of a parallelogram bisect each other. Okay, this is the position vector of midpoint of both diagonals OC and AB are same. So position vector of midpoint of diagonal OC is A plus B over 2. Position vector of midpoint of diagonal AB is also A plus B over 2. So position vector of midpoint of both the diagonals we have got same. So position vectors of both diagonals same means they bisect each other. Okay, in this way this important theorem of vector can easily be proved. I hope that you found this video helpful. Thank you for watching. If you have not subscribed my channel, please do not forget to subscribe my channel so that I will be encouraged to make similar type of videos, and also press bell icon so that you will be informed about my coming videos. Thank you very much.